Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see second chapter of the book Loop Quantum Gravity for Everyone, that is Gravitation. In the first video, we showed fundamental concept of this book and introduction of this book, which was authored by Rodolfo Gambini and George Pullin. In this video, first of all, I will explain history of unification of forces in physics. Thereafter, we will see general theory of relativity that explain gravitation. Let us start. We know that in 19th century, Maxwell gave his four famous equations that could unify electricity with magnetism and predict that what is electromagnetic wave. And thereafter, physicists found that light is nothing but electromagnetic wave, and so optics was merged with electricity and magnetism, which is collectively known as electromagnetic theory. Here I have shown electromagnetic wave in which electric and magnetic field are perpendicular to each other and perpendicular to the direction of propagation. Thereafter, physicists found quantum mechanics in the beginning of 19th century. Thereafter, Einstein came up with special theory of relativity, and by unification of special theory of relativity with quantum physics, physicists found quantum field theory. And thereafter, physicists attempted to quantize electromagnetic theory, and physicists got first quantum field theory, which is known as quantum electrodynamics. We can see many implications of electromagnetic theory or electromagnetic interaction in day-to-day life. There are many gadgets which use fundamental concept and principles of electromagnetic interactions, whose mediator particle is photon. In 1960s, physicists find more two interactions at sub-constituent level. Physicists also found that atom has sub-constituent particle like neutron and proton, which has more sub-constituents like quarks. And strong nuclear force for interaction is responsible for binding nucleus together by balancing electromagnetic repulsion, which was created by protons, various protons. Weak nuclear interaction is created because of particle decays, and which is manifested at astrophysical levels, which is also manifested in nuclear phenomena. These two forces are not visible for us in day-to-day life and for our naked eye, but there are several implications of these two forces in physics at conceptual level. Quantization of strong nuclear force is known as quantum chromodynamics, and quantization of weak nuclear force is known as quantum flavor dynamics. In 1950s and 60s, physicists attempted to unify weak nuclear force with electromagnetic interaction, which is known as electroweak theory, which was successful theory. And thereafter, physicists attempted to unify strong nuclear force with weak nuclear force and electromagnetic interaction, which is known as grand unified theory. I will explain each new term in my YouTube channel in separate videos. But here, whatever I have been explaining, which is only necessary for understanding gravitation. But it requires more time to explain all these concepts mathematically, that I will cover in separate videos. In quantum field theory, there is a one theory which is known as Yang-Mills theory. It is a class of quantum field theory in which there are several electric and magnetic fields which are interacting with each other, and it explains grand unified theory successfully. Yang-Mills theory is also fundamental theory to understand mathematical framework of loop quantum gravity, and that is why I have introduced Yang-Mills theory here. Let us see some fundamental concept of gravitation according to this chapter. We know that in 17th century, Newton came up with his universal law of gravitation, according to which gravity is proportional to the product of masses and inversely proportional to the square distance between them. Newton was successful in explaining solar system, but not completely. There are some flaws, like according to Newton's gravitational theory, gravity propagates instantaneously, spontaneously, which is impossible according to special theory of relativity. And it is Einstein who found this flaw. In 1905, Einstein came up with special theory of relativity, according to which speed of light is constant, and that is why gravity cannot propagate instantaneously in space-time and spontaneously in space-time. And another principle of special theory of relativity is law of physics are invariant in all inertial frame of reference. And Einstein also identified that there are many flaws in Newton's gravitational theory. So in 1915, he came up with his general theory of relativity by giving his famous field equation, that is r mu nu minus 1/2 r g mu nu minus lambda g mu nu is equal to 8 pi g over c raised to 4 t mu nu. Einstein used curved geometry or non-Euclidean geometry or Riemannian geometry to explain gravity as deformation of space-time. Earlier, we showed that gravity is not fundamental force or interaction. Rather, it is deformation of space-time. And that is why it is difficult to quantize gravitational force in the framework of quantum field theory. By defining this term as g mu nu, that is Einstein tensor, we know that g mu nu is proportional to t mu nu by considering cosmological constant is equal to 0 for steady state theory. So g mu nu proportional to t mu nu. G mu nu is Einstein tensor and t mu nu is energy momentum tensor, which tells that there is interplay between mass and space-time. Einstein's tensor defines curved space-time, while t mu nu defines mass term in gravity. So there is a reciprocal action according to this interplay, which tells that mass tells space-time how to curve, space-time tells mass how to move. This sentence was uttered by John Wheeler, and earlier many times I explained this sentence in my YouTube channel. So there are several predictions in general theory of relativity regarding gravity. First prediction is precession of perihelion of Mercury. We know that in solar system, all planets are rotating around sun in elliptical path. But according to general theory of relativity, this elliptical orbit is also rotating around sun. And there is a precession of perihelion for each planet. Einstein gave precession of perihelion of Mercury, which was exactly same according to mathematical answer. And that is why this was the first successful proof of general theory of relativity. Another thing is, we know that in flat space-time, natural trajectory of object is straight line. While in curved space-time, natural trajectory of objects is curved, as heavier mass will create more warping around it. Earlier, I gave one example that if kids are playing in the amusement park and jumping in the rubber membrane, heavier kid will create more warping. So this is how we can have explanation of general theory of relativity. And in curved geometry, natural trajectory of object is also known as geodesic, which means shortest distance in curved space-time. So this was the first proof, that is precession of perihelion of Mercury. Second proof is gravitational lensing. For example, we are receiving electromagnetic waves from distant star which is situated backside of sun. Because of sun's gravitational pull, whatever light we are receiving will be bent near sun. So at earth, these light seem to be moved in the outward direction, and we will see these stars in zoom format or zoom mode, which is known as gravitational lensing. Here I have explained gravitational lensing in simple words. It is more complex concept that I will cover in separate video. So this was another successful proof of general theory of relativity, and it was observed by famous astronomer and observer, British observer Arthur Eddington in during solar eclipse. As in the normal days, because of sunlight we cannot observe such kind of phenomena, so Arthur Eddington observed gravitational lensing during solar eclipse, and this observation made Einstein star in general relativity and in physics community. So this was the second proof of general theory of relativity. Third prediction was gravitational wave. Einstein predicted existence of gravitational wave. According to this phenomena, there are ripples in space-time because of acceleration of masses. But Einstein believed that as its value is very less, very small, he was doubted that we cannot observe gravitational wave in near future. But in 2015, in LIGO, physicists observed gravitational waves which was produced by two black holes which were away near 1500 million light years, and this was third proof of success of general theory of relativity. Fourth thing is, which is bizarre and interesting, is black hole. According to this object, gravitational collapse of star or galactic collapse is so intense that even light cannot escape from event horizon. And further, physicists named this object as black hole, as even light cannot escape from the surface, which then we call event horizon. So this is why general theory of relativity is very, very interesting theory. Many physicists call it very beautiful theory of modern physics, and it is general theory of relativity in nowadays which explains gravitational force completely. Another thing is, it is difficult to unify general theory of relativity in quantum field theory. Why? Earlier I explained that quantum field theory is background dependent, while in general theory of relativity it creates spacetime itself, so it is background independent. So it is difficult to quantize gravitational force with rest of three fundamental force. And thus there are many proposals of quantum gravity like Regge calculus, causal dynamic triangulation, causal sets, string theory, loop quantum gravity, twistor theory. Among all of them, I explained that string theory and loop quantum gravity are promising. Among these two, I worked in loop quantum gravity, which was originated from general theory of relativity, and that is why it is background independent. So this is what is called gravity, according to this book, as complete explanation of general theory of relativity or gravitation requires to study many books. First, classic books, which was written by John Wheeler, Kip Thorne, and many others, has 1300 pages. So you can understand that it is very difficult to understand gravity with mathematical framework. But in this lecture, I have only covered fundamental results of gravitational theory or general theory of relativity. In the next chapter of this book, that is Look Quantum Gravity for Everyone, we will see quantum theory. By seeing quantum theory, you are ready to understand how to quantize gravity with quantum field theory at fundamental levels with simple words. Thanks for listening and watching. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this explanation, you can ask in the comment section.